Hello everyone, I hope you are doing well. So in today's video, I'm actually going to go through the 2018 Maths Methods Exam 2 for the Northern Hemisphere multiple choice section. Yes, I've had some students tell me to finish this paper. Yeah, so I'm just going to get this paper done and do the extended response in the next video. If you guys want any, private tutoring, please make sure to, email me down below. I can give you my information. Perfect. So let's smash through this paper. So question 1. If f(x) of x is this, the period and range of the function is... Okay, so the period is just 2 pi over 4. And it's just 2 pi times 4 over pi. These cancel out, it'll become 8. Looks like only B is your answer because it's the only one that has 8. Not bad. The diagram below shows part of the graph of a polynomial. The possible rule for this function is what? Okay, so this point over here and this point over here and this point will create factors of x minus 3, x minus 1. But this one here, the x plus 2, it'll become a squared because it's actually being reflected. So we make sure to do that. We also know one thing extra. If it started on top, like for example, it went like this, it started on top, it becomes positive. But here, it started at the bottom, meaning that this is a negative. There has to be a negative. Let's look at the answers. This one's not right. This one has x plus 2 squared, x minus 1, x plus 3. Nope, it doesn't have a negative. C, x plus 2 squared, x minus 1, and negative. C looks right. It has this here. It has a negative dilation. The other ones are all wrong. A discrete random variable has a binomial distribution with a mean of this and a variance of this. The values of n, the number of independent trials in the P, the probability of success in each trials are what? So we know that NP, the expected value, the mean is 3.6. And the variance, which is NP, I think 1 minus P, is 1.98. So I'm just going to use my calculator and solve this. So menu, go to algebra, solve systems with equations, and for n and P. Yep. All right. So we have n times P is equal to 3.6, and here n times P times 1 minus P is actually equal to 1.98. Enter, and we get our values here. Very nice. Control enter that, 8 and 0.45. Looks like D is your answer. Question 4. If A and B are events from a sample space such as the probability of A is this, probability of B is that, and probability of A union B is that, then the probability of A intersection B dash is what? So what are we trying to find? Well, if I just draw a nice Venn diagram here, where we're actually trying to find is, if we draw a nice 2 circles here, say this is A and this is B, we're trying to find actually this section over here, this part of the graph. All right, to find out, what do we know? It's just the probability of A minus the actual intersection, this intersection. Probability of A union B, A intersection B. That's what we want to find. Well, what's A intersection B? Well, we can use the addition rule because we have all these values over here. So it's what? So the probability of A intersection B is 0.6 plus 0.3 minus 0.7, which is 0.9 minus 0.7, 0.2. Now we have that, that's easy. Now, what's the probability of A? It's just 0.6 minus 0.2. That is 0.4. So, choose E as your answer. Nice. A set of 3 numbers that could be a solution to this equation is what? Okay. Well, I'm just going to have a look at this and create these as factors. So, this one will be what? X minus 3, X minus 4, X minus 7. And let's look at this part here. This, it's a positive 84. So if I multiply this here, so negative 3 times negative 4, it will be positive 12. And we multiply by negative 7. The problem is we don't even have to, because if you 12 times negative 7, it will have to bring a negative. It would be like negative 84. So A is wrong. Let's try the next one. So the next one. That's how I would do this. Or you can actually, what you can do is you can pretty much expand it using your calculator and see if it brings this. But yeah, this is just a quicker way that I would do it. So let's do the other one. So it's x plus 4, x plus 3, and x minus 7. Okay, so 4 times 3 is for a 12, so 12, and times negative 7. Again, it still brings a negative. We want a positive. So that's wrong also. What about this one? So x plus 2, x plus 1, x minus 21. Okay, this one over here, these two bring a positive, and we multiply by, again, still negative, wrong. Let's choose D. Let's see D. So D is x plus 2, x minus 6, x minus 7. So this one over here, 2 times negative 6 is negative 12, and we multiply by negative 7. Aha, positive. Choose D as your answer. Even this one would bring a positive, but the problem, so what's 12 times 7? It's 84. The other one, this one, I just want to have a look at the next one just to double check. X minus 2. Okay, no, that brings a negative number. I just realized. Okay, yeah, so D is the only answer. The sum of the solutions to this equation for x as an element from 0 to pi is equal to what? Very nice and easy. So I'm going to use my calculator. So what I'm going to say is solve root 3 sine. So root 3 sine 2x equals negative 3 plus 2x comma x, given from 0 to 2 pi. And it gives you these ones. And I'm going to find the sum, I'm just going to add those. So I'm just going to add those here. And that's 13 pi over 3. So D is your answer. Question 7. 6 balls numbered from 1 to 6 are placed in a jar. A ball is taken randomly from the jar and its number is recorded. This ball is then returned to the jar. So it's returned to the jar. So there's replacement. And a second ball is then taken in randomly and its number is recorded. The sum of the two recorded number is then calculated. The probability that the sum of the two number is 7, given that the first recorded number is odd. This is conditional probability. So we want the probability that the sum of the two number is 7. So sum 7, given that the first recorded, so first number is odd. This can be just simplified to what? The probability of, the sum, 7, intersection, so the first num odd, all over the probability of the first num odd. Okay, doing this. Let's really think about it. So we want, there's only 1 to 6. These are numbered 1 to 6, and there's only 2 balls we're taking out. So to get, what is the probability of just getting the sum of 7? Well, we can get 6, 1, 5, 2, 4, 3, 3, 4, 2, 2, 5, 1, 6. These are the only ones that can give us a sum of 7. And we want them to intersect with being odd. So which one's odd? The first number is odd. This one's first number is odd. First number is odd. This is, yeah, first number odd. So there's 3 of them. Okay. Because we have 3, and what is the total? Well, because they're balls that are like numbered to 1 to 6, so you would have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah, and we would have like 1, 1, 2, 1, 3, 1, 4, 1. So the total is 6 times 6, 36. And we have 3, so it'll be 3 over 36 all over. The probability that the first number is odd. Well, if you look at here, if let's say this was the first number, because you can see these are the first numbers, these ones over here. If we want the odd ones, this all would be odd, the first numbers. This also will be odd, and this also will be odd over here, which is pretty much half the numbers if you really look at them. Yeah. So it's pretty much half. It's 18. So 6, 12, 18. So 18 over 36, which is just half. So multiply by half. So so we're saying 1 over 12 divided by half. So times 2 over 1, which is 1 on 6. So C is your answer. Hope that's right. Yeah, this is like a year 11 textbook question. I've seen this question before, so yeah, you would have to use this kind of diagram over here. Question 8. Part of the graph of y equals f of x is shown. The graph of f dash of x is best represented. Okay, the best way to do it is look at the slope. It's all negative. We can see it's negative, 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 negative. So it's all negative. So what it means that the f dash of x, the graph should be all below the x-axis. So A is wrong, B, C, D. Only E is right. It's only, can you see how it's below? And yeah, that's the only one that's right. A continuous random variable x has a normal distribution with a mean of 40 and a standard deviation of 5. The continuous random variable z has a standard normal distribution. The probability that negative 2 to z is this is equal to what? Okay, so we can just say x minus the mean, which is 40, all over the standard deviation, negative 2, so x minus 40, negative 10, x is 40 minus 10, which is 30, so it'll be like the probability of 30 less than x less than, so x minus 40 over 5, 1, x, oops, x minus 40 is 5, x equals 45. So that's that. Is that one of the solutions in here? Alright, let's double check. Which ones looks like this? So 30 to 45? No. Okay, I think here they're trying to trick us. But I personally cannot be bothered. So what I'm going to do is I'm just going to use my calculator here. Okay, just to make my life easier. Yeah, because this was, none of them have this kind of notation. So what I'm going to do is go on my calculator and go on menu and go on probability distributions and normal CDF. Now I'm going to find the normal distribution for negative 2 to 1 for when it's, the normal distribution, the standard normal, which is 0.81. Now I'm going to try to check the first one. So I'm going to bring this over here. And we're saying from 40 to 55. And your mean is 40 and your standard deviation is 5. They're not the same. So that's wrong. The first one's wrong. Let's check the next one. So we're saying 35 to 50. Enter. Aha! They're the same. So B is your answer. That's the best and quickest method. It's the most safest method you can use. Just, put in your calculator and see which one works. The range of the function from negative 1 root 2 to root 2 of f of x is this. What? Okay, I'm just going to use my calculator and sketch it. So, go on graph and say, we want 2x to the power of 3 minus 3x to the power of 3. What did I do? 2x to the power of 3 plus 4. Given negative 1 root 2, so negative 1 root 2 is less or equal to root 2. Enter. Okay, this is our graph. Well, the range is, here, this point over here, which is included, so this to the max here. So just let's have a look at what's this point. Well, if we go to, let's take this function over here. Let's take this whole function. Oops. Okay, let's just, let's just take it and go on menu, calculus, minimum, put the function in here. Oh. Let me just take on this part over here. So I go calculus, minimum, put this function over here, comma x, comma, from this. So this to this. We get this. So if I take this and given this, okay, 4 minus root 2 is this point over here. So, but it's included. So which one has included? Only E is the one that includes it. So choose E. I'm not going to bother finding the actual other part. Well, because, it's just too much. Yeah, because if this one has the only one that's included and it's actually included, it can only mean E is your answer. The maximal domain of the function g of x is what? Okay, this is not too bad. I'll just go on my calculator and just say domain of natural log negative 2x, comma x. Aha, gives you over here. This is your answer. So we're saying from negative infinity to 0 not included. Well, this can be just written as all reals minus anyway. So B should be your answer. Yeah. 12. The average value of f of x over the interval this is this. Find the value of a. Nice and easy. I'm just going to use my calculator. I'm going to say solve 1 over a minus 1. The integral from 1 to a of x squared minus 2x from x must equal 13 on 3, comma a. And we get these two values, but a is actually greater because it's from the interval 1 to a, so a must be greater than 1. So a equals 5 should be your answer. Question 13, the function f has the property this for all real numbers x. A possible rule for this function is... Okay, I've seen these kind of common questions. The fastest way to I'll do this question is just by like defining a function. For example, let's define the first one, which is what? 1x squared plus 4. And let's write this property. So we're saying f 2x equals f of x squared minus 2. Okay, this is false because it would say true if it was true. So that's not right. So I'm going to now define the next function, which is just cos x. And let's enter this. Still not true. Let's try the next one. 2 natural log x squared plus 1. Still not true. Next one. E to the power of x plus e to the negative x. True. So D is right. The graph of the function f is obtained from the graph of the function g with the rule g of x this by a dilation of factor of half from the x-axis, that reflection of the y-axis, translation in the negative x and a translation for units in the negative y direction. In that order, the rule of f is what? So the graph of f is obtained. Okay, so these are the transformations that's happened. So the first one is a dilation by a factor of half from the axis, which is the same as parallel to the y-axis. So we just halve g of x, which is 3 over 2 cos x minus pi on 6. Done. Next one is a reflection in the y-axis. If we're reflecting in the y-axis, so a reflection in the y-axis. So a reflection in the y-axis will have g minus x over here. So it'll be 3 over 2 cos negative x minus pi on 6. Alright, so a reflection in the y-axis. A translation of pi over 6 units in the negative direction. So it'll be half g negative, so reflection, a translation of pi over 6 units to the negative x section. So it'll be x plus pi over 6, 3 over 2 cos negative, oh my god, it's too much, wait, let me just move this, negative x plus pi on 6 minus pi on 6, and a translation of 4 units in the negative y direction. So that'll be 4 units, negative 4. So it'll be 3 on 2 cos, let me expand it all. So negative x, negative pi on 6, minus pi on 6, minus 4, which is 3 on 2 cos negative x, negative pi on 3, minus 4. Which one looks like that? A is your answer. Question 15, if, so negative 3 to 2 is this, 2 to 3 is this, the value of negative 3 to... So this is a kind of a common question, so the best way that I would do this question is, but drawing a nice graph. And so we're saying from, let's say this is negative 3, and this is 2, and this is 3. We're saying from negative 3 to 2 is like negative, so it's probably here. And from 2 to 3 is positive, so it's like 10 here. So we're saying from negative 3 to 3, it's just the addition of both of them. So 10 minus 8, which is 2. Choose A. Question 16. Let f of x be this and g of x be this. The domain and range of the function is respectively is what? I'm just going to do this on calculator. So I'm just going to say, what is the domain of f? So we're saying negative natural log of x squared plus 1, comma x. Okay, so it's all reals. So I'm just looking at Let me just see which ones. So C is not right and D is not right. What about the range? So I'm just going to graph it. I'm just going to graph this graph. Done. Okay, so it goes to negative infinity to 0, but 0 is included. So range is negative infinity to 0 included. Or this can be written as all reals negative a union inclusion of 0, because it's included. So here's your answer. If f of x is an antiderivative of f of x, and f of 4 is negative 6, then f of 8 is equal to what? Wait, if f of x, so f of x is an antiderivative of f of x, yes, then f of 4 is that, and f of 8. Okay, well, let's just find, so because this is 4 and this is 8, let's say 4 to 8 of f of x dx is what? Well, we know that this will be f of x from 4 to 8, which is f of 8 minus f of 4. And we want f of 8, so we have to bring that positive 4 there. So it'll be 4, 8, f of x dx plus f of 4. And f of 4 is what? Negative 6. So this over here is just write it as negative 6. And that's equal to f of 8. Which one does that look like? Yeah, it looks like E. I think there was a similar question. There's a similar question in the past exams that had a similar question like this. Yeah. So yeah, this question's not bad. It's just you need to know the property, like the actual definition of the integral, what the antiderivative is. Yeah, not too bad. Consider the graph of f and g below, which have the same scale. If t transforms the graph of f, so this one, to g, then which one of it is? Okay, let's look at the first one. So the first one is there's no dilation, but there's a translation to the left by 3 units and translation down by 4 units. Let's do that here. Well, we're translating it to the right. So this is x plus 1. So this is 1. It'll mean that this here will translate over here. Negative 2. And it will be translating down. No, that's wrong, because there should be a reflection. Because then it would just be translated like this. It will just be like this. There's no use, actually. Oh, no. It'll look like this, actually. It's wrong. Let's look at the next one. Okay, so there's a reflection along the y-axis. So if we're reflecting it along the y-axis, so this over this point over here will be x negative 1. And this over here would be like this. And this over here would be like this. And then again, we're translating it 3 units to the left. So this over here would be translated 3 units to the left, which is negative 4. No, this is x equals negative 2. Absolutely not. Okay, let's try the next one. This is the best way that I would do it. Yeah, like just the guess and check. So this one here, there's a reflection along the x-axis. So here, if I was reflecting it, this over here would be y equals negative 2, which is true for this one. And so if we reflect it, it will look like this. And then we translate it to the left by 3 units. So if we translate this whole thing to the left, this is x equals 1. Yes, so if we translate this whole thing, let me just draw this. If I translated this to the left, so nicely, so it'll be over here, which is, yes, this will be x negative 2. Okay, so we have the y and x equals negative 2. The graphs look similar, but I'm not too sure, because here, like, look at over here. It was originally very thin, but here it's actually thick. And remember, they are saying the same scale. So, isn't there supposed to be some dilation happening over here? But there isn't. Yeah, I mean, they look similar. Look, I'm gonna just put a question mark on this one because I'm not too sure. I'll have a look at the next ones and see which one looks better. Because yeah, there has to be probably some dilations. I mean, look how thick this thing is here. And look how thin the other one is. Next one. So, okay, we have a dilation happening now. And we have also a reflection along the y-axis. So this first, so reflection along the y-axis. So let's have a look here. So it'll look like this. Okay. And then that thing here is reflected along the, it becomes thicker, becomes bigger, like the thickness due to the fact it's dilation by factor of 2 parallel to the x-axis. So this thing over here becomes thicker. So it will look like, maybe look like this. Okay. And then it's been also reflected along the x-axis. So if this thing has been reflected, so, okay. So if this is reflected along the x, so this will be y -2, then this whole thing is going to look like this. Now it looks much similar because the thickness looks similar, but what else are we missing here? Okay, we got y equals -2. What about x equals -2 here? Did I make a mistake here? So, alright, so, okay. So if I was going to expand this one, if I multiply by this, okay. Alright. I think, yeah, this one D looks the most perfect. Well, C was close, but the problem was the thickness wasn't right. Yeah, so I think it's just D. I'm just going to make sure. I just want to double check the last one too. Because this question's actually quite tricky. Because, yeah, it's, look, D was similar. C was similar, but D looks the most perfect. What about this one over here? So a reflection along the y-axis. So if we reflect this whole thing, okay, and then a reflection along the x-axis. So if I just reflect this whole thing, it will be, and then this whole thing will, okay, if I was reflecting this, like this, but this is a dilation by a factor of 2 parallel to the y-axis, so, but we want the thickness to increase, so, yeah, D is the only one that was right. Here, if you really expand this, yeah, nah, so, yeah, this would shrink it. Pretty much that Y would shrink the graph more. So only D is the most right answer here. I gotta check the answer. I'm not actually sure for this one. Yeah, wow, this actually question's quite, I think the best way I'm gonna do this, and I'm actually gonna be honest, is I will, just to double check it, I'm just gonna do something. Well, I know it's a truncus, and it's a positive truncus, and let's just say it's some value. Let's say it's 1 over, because it's a positive truncus, and x minus 1 squared, because that's this one over here, and plus 2. I'm just going to sketch it, and I'm going to apply that transformation to what's happened to it. So let me just say that, let's say define as f of x. Let's redefine it as 1 over x minus 2, so x minus 1, x minus 1 squared plus 2. Okay, and let's try to do D. So we said x dash negative 2x, y dash negative y. So it'll be negative x dash over 2x Okay, and negative y dash equals y. So I'm saying that this is negative y equals this function over here, but in here we're putting negative x over 2. Expand that and we get this, and we want to solve answer comma y. And we get this, and I'm just going to take this over here. I'm going to graph it. Okay, so does that look similar? So negative 2, yep, has that negative 2 in there. It also has an ampersand top at negative 2. And its thickness is, yeah, totally, absolutely. I just want to graph the original graph to double fully check, because, I just want to make sure. So we said the original function was what? Well, we said it was this. So it was f of x. Okay, so can you see how here it's very thin and here it's very thick? So yeah, the only possible, yeah, that should be the answer. I hope it is. I'm going to double check it anyway. Can you see how it's very thick here? Whereas here it's very thin, so yeah. So yeah, hopefully D is right. I'm going to double check it anyway. A box contains 2,000 marbles that are either blue or red. There are more blue marbles than red marbles. Random samples of 100 marbles are taken from the box. Each random sample is obtained by sampling of the... So it's replacement, okay. The standard deviation of the sample distribution for the proportion of blue marbles is this. That's... Okay, so the standard deviation of the sample distribution of the marbles is this. Then the number of blue marbles in the boxes are what? Okay, so we know that the formula for standard deviation, so standard for a proportion is what? It's in P1 minus P1 minus P over N. And we know that's 0.03. We know our N here is 100. Be careful, not 2,000. That's the population. We want the sample size. So 100 P1 minus P. I'm going to use my calculator to solve for this. So I'm going to say solve 0.03 equals square root P times 1 minus P over 100, comma P. Okay, we get two values, but be careful. Here we're dealing with blue marbles. So, and we know that there are more blue marbles than red marbles. So the only right answer would mean that this one here is a high number. So this one over here, we multiply it by the 2,000 to find the actual number, which is 18,000. So D is the answer. Let G be a... So let f be one differentiable function such that f of 3 is this, f of 7 is this, f dash of 3 is this, f dash of 7 is this. The function g is differentiable, and g of x is the inverse of f. For all x, find g dash of 7. I'm just going to draw. I'm going to just sketch. Because this one, yeah, they didn't give us a lot of information. I think here, we just need to use some... just going to sketch it. Okay, let's just make a nice scale. So, let's say this here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8. And, well, let's sketch f of it first. We have 2 points for f. Well, we have, when it's 3, it's 7. When it's 3, it's 7. So right over here. And when it's 7, it's 8. Okay. We also know the gradients, because when it's f on 3, the gradient is 2. So I know if I was going to draw a straight line, if it was 1, we know it's 45 degrees. So it must be greater than 45 degrees. So it's probably look like this. Not like this, actually. It looks like very like this. And we know at 7, it's steeper than the original. So it's probably like something like this. It's much steeper. Knowing this, probably they join. So I'm just going to, I don't know, just join them. Like that. nicely join them. Okay, and so, okay, just want to make sure. So this is here 3 on 7. This is 7 on 8. And then the function g is the inverse. So g of x is just the inverse of f. So I'm just going to draw y equals x here as a reference. Oops, that's not nice too. I don't know if this is the best graph. The scales are so bad. Oh, yuck. But yeah, something like this, at least. So yeah, the scales are very bad. But yeah, so say this is y equals x. And I'm just going to reflect this. So we know this point will be 7 on 3. So it will be 7. So it's 7 here. 3 is over here. So it's around this point here. And the other point will be 8 on 7. So 8. Oh my god, this is not even good to draw. Wow, the scales are very bad. This is not good, but okay. I'm just gonna not even bother scaling it. Just reflect this. So if I was gonna reflect this, it would look like this, and this over here. It will look like around something like this. Something like this. Something like that. Alright. What can we know? Well, what's g dash of 7? So remember, this is 7 right over here. This was supposed to be 7. So this was supposed to be 7 on 3. So this point over here, g dash, it means what is the gradient? Well, if you look at the gradient over here, we said it was 2. Here, what's happened? It's like it's become less steeper. Here, it's very steep. Here, it's become less steeper. So it must be less than 2. So so this is like, it's pretty much, it's the reciprocal of 2. So it should be 1 over 2, the gradient of this one over here, as we can see. That's actually a property, I think. Yeah, so if this was 2 here, the reciprocal will give you this over here. So yeah, I think A is your answer. So yeah, so B is absolutely wrong. The other one's very small, very, very small. But yeah, I think, yeah, the properties, I think it's the reciprocal. I've seen like a property, yeah. Hope that's right. I gotta double check the answers anyway. And yeah, I hope this helped you in a way. Yeah, so the inverse, it's just the reciprocal of the gradient. That's an actual property, yeah. You should have that in your formula sheet. That's actually, yeah. That's a good property to have in your formula sheet. I'm going to double check everything here. I hope these are all right. I may have made 1 or 2 mistakes, but yeah, that's not bad. Thank you guys for watching. Please make sure to like and subscribe to this channel. And guys, if you want more videos, please comment down below and, subscribe to this channel. The more support I get, the more motivation I, get to do these videos. And guys, thank you so much. I hope you guys have a great day and take care of yourselves. Bye-bye.